Hello everyone, let's start my first lecture. So today I explain syllabus and some explanation of graphs. So first we look at my syllabus in international trade. Okay, I'm Chang-Soo, lecturer of international trade lecture. This international trade lecture is intermediate level course, right? After finishing introductory level course. So there exists some requirements formally. Statistics, introductory level microeconomics, introductory level macroeconomics. Also, I emphasize some your requirements. You are taking course for mathematics for economics and intermediate level microeconomics, right? That is requirement. So the language of intermediate economics course is some calculus, some require you some mathematical skills, calculus skill, differentiation and integration. So this is really important to if you really want to get high marks, high grade. Okay, let's go outline of the class. This course tries to help students to understand the theory of international trade and trade policies issues. Before midterm exam, we study theory part of international trade, Heck-Shorley model and Ricardian model. After midterm exam, we study trade policy issues. Okay, theory part explores the motives for and implication of patterns trade between countries. Motivation and implications of patterns of trade. Now think about what is patterns of trade. For example, why Korea export manufacturing car to Australia and import Australian beef, for example. That is patterns of trade. From the perspective of Australia, these patterns of trade means Australia exports agricultural goods and imports manufacturing goods from Korea, right? That is patterns of trade. Theory part explains these patterns of trade between countries. The class proceeds by introducing successively more general models of trade. The theory part focuses on Ricardian model and Heck-Shorley model. Okay, so before midterm exam, we study Ricardian model and Heck-Shorley model. The basic idea of Ricardian model is motivation of trade between two countries is differences in productivities, labor productivity or overall productivity. Because of difference in productivity, two countries trade with each other and consumption and production increase in both countries. Two countries are winners. Participating, two countries are winners. And Heck-Shorley model. The motivation of trade between two countries in Heck-Shorley model is differences in factor abundance. Labor abundant country or capital abundant country, like this, right? And after midterm exam, we study policy issues, right? This policy issues is based on instruments of trade policy. Instruments of trade policy. Instruments of trade policy means tariff, for example, subsidies, import quota, like this. Using this kind of tools, trade policy activated. And chapter 10, we studied the arguments for free trade and restricted trade. Why free trade better than restricted trade? And in sometimes, why protectionist policy better than free trade policy? This policy part also introduced case studies providing students with real world example that clearly illustrate the theoretical arguments. Blah, blah, blah. Right? And more important than this one is this one. The first 6 lectures, the first month cover the microeconomic foundation for international trade. Lots of students are not ready to start international trade lecture because this theory part, Heck-Shorley model or Ricardian model based on microeconomic foundation. So I give us some lecture for this, foundation for international trade. Okay, so we study here consumers, utility maximization problem, producers or countries, value maximization problem. And we introduce general equilibrium framework to start international trade lectures. Okay? The goal of this course is to teach students how international economists think and approach to important policy problems after technical and intuitive mastery of the important international trade theory, Heck-Shorley model and Ricardian model. Okay, then some attendance rules. No recognition of absence due to employment and etc. by senior or foreign students. So you should be careful for this. Also, a mathematical requirement. College level calculus skill requires to solve test questions successfully. And you want to get high grades, right? This mathematical skills means, as I said before, differentiation and integration skills. This one is equivalent to international baccalaureate math and calculus A, B, and BC in AP, Advanced Placement Tests. Students fail if skipping more than 9 times or failing to take 1 over 3 exams. Should be careful for this. Evaluation like this. First exam, after microeconomic foundation lecture, we have first exam 15%. Midterm exam, after theory part of international trade, 30%. And final exam covers policy issues, 40%. Attendance, 15%. But this semester is really emergency situation because of COVID-19 situation, right? So I'm not so strict on attendance. If you skip more than 9 times, 8 times, you can receive, all the students can receive 15%. In some, attendance score is not so important in the final grade. This just decides you fail or pass, right? And your grade level decides only by test scores. Should be careful for this. Violation of academic integrity, cheating, plagiarism, false attendance, false documentation in and out during the class is prohibited in my class, basically. Textbook, International Economic Theory and Policy by Krugman and Obstfeld. Okay. I already explained this. So, first 2 lectures focus on 6 lectures on microeconomic foundation, right? After that first exam, then we start international trade lecture theory part, Ricardian model and Heck-Shorley model. Then we have midterm exam. Okay. After midterm exam, we have policy part, then final exam like this. Okay. So 3 misconceptions. Number 1, attending the class is not enough to understand the contents. You have to study. I emphasize your own preview and review. Right? And number 2, skipping class is not enough. Should not be okay. You cannot understand subsequent chapters if you do not understand the previous ones. So economics course have some features quite different from politics or business studies. Economics course has sequence, right? Sequence matter. Number 3, in and out, and use a mobile phone during the class are not possible. Okay, that is my syllabus. And so from now on, we start first lecture, microeconomic foundation. But microeconomic foundation focus on utility maximization problem and value maximization problem like this. But lots of students have some mathematical problem understanding this microeconomic foundation. So I'd like to explain graphs. Okay, graphs in economics. All right, this is a foundation of foundation of microeconomics. Okay? So explain this. From here, I explain the graphs, right? Number one thing from here, now think about this kind of graph, right? So Y variable is number of soda sold, right? So demand for a cold drink, for example, right? X variable is outside temperature in Fahrenheit. So outside temperature goes up, we know that demand for or consumption of cold drinks increase, right? So we said then, now think about this kind of production, just function, y equal fx. So two variable case, one independent, one dependent variable, right? So here, y variable is demand for cold drinks. X variable is outside temperature. Outside temperature goes up, then demand for example, ice latte, ice americano increase, right? That is positive relations. X increase, Y increase. Then we can say positive relations, right? Also, okay. So in these positive relations, there are three types of positive relations. Anyway, positive relations means X increase, Y increase. There is three types of positive relations, X increase and Y increase. This positive relationship classified into three. Okay. Before that, I will explain some mathematical notation. For example, X value outside temperature 40 degree, then demand for ice americano 30 unit. Okay. At point C, at earlier graph. At point D, this one changes to X, Y equal change it to outside temperature 60 degree. Then demand for or consumption of ice latte is 50 unit. Okay, so outside temperature goes up. X increase 40 to 60. Then consumption of good. Y variable increase 30 to 50. So positive. Okay, using this, I'd like to explain some notation. So originally, starting value of X 40, starting value of Y 30. Ending value of X 60. Ending value of Y is 50. Okay? Outside temperature, and this is a consumption of ice latte. Change like this from starting to ending. Okay? From here, I'd like to introduce some notation. First, change. This delta means changing, right? Change in X. Change in X defined by ending value of X minus starting value of X. Okay? So that means ending value of outside temperature 60 in Fahrenheit minus 40. So when we moving starting to ending or A to B, change in X is 20 degree. Outside temperature goes up by 20 degree, right? And similarly, we can say change in Y. Change in Y is same. Ending value of Y. Consumption of ice latte, ice americano, and ending situation, right? Minus starting value of Y is like this. That means 50 minus 30. 50 minus 30. So 20. Right? That is change in X, change in Y. Then we can define changing rate, change in Y over change in X. Okay? Change in Y over change in X. What is this? Change in Y is 20. We calculated already. Change in x, 20. So that is 1. Okay, that is changing rate. Changing rate. That is, we say changing rate. Changing rate. Definition of changing rate. Change in y over change in x. And I'd like to introduce slope. Slope. Definition of slope is absolute numbers of changing rates. Okay? So absolute numbers of changing rate. Change in y over change in x. Then absolute number of 1 is just 1. So same. Changing rate is equal to slope in this case. Okay? So like this. Right? So positive relation, I said there are 3 types of positive relations based on changing rate or slope. If the changing rate is constant numbers, we say positive linear relations. So graph of this case is this one, moving here. So now think about 3 types of y equal x. And x, y, and third type is like this, right? Y equal fx. So first case, for example, like this kind of graph. Think about this kind of graph. X increase. Originally start at this point, 40 degree. Consumption of good one is 30. Outside temperature goes up to 60, then ending value of y, 50. Okay? So we're moving from here to here. Right? In this situation, changing rate, we calculated changing rate there. Changing rate is equal to 1. Now, we're moving to, for example, here. From here to here. That means outside temperature increased to 80. Right? Then demand for consumption of as Americano, for example, 70 increase like this. We moving here to here, we can calculate changing rate again, and we realize that we moving here to here, that is equal to 1. Changing rate is equal to 1. We moving here to here, changing rate is equal to 1. Right? From you moving here to here, changing rate is same to 1. You moving here to here, every point, changing rate same. So we said this is case of constant positive relations, positive relations, x increase, y increase, right? And with constant slope or constant changing rate, right? That is first case. Second case is, so that is like this. Anyway, think about definition of a change rate and slope in mathematical terms. Geometrically, this changing rate can be explained using this. For example, you're moving here to here, then we can make this kind of triangle, isn't it? Right? And what is this? Width of this triangle is 60 minus 40. That is definition of a change in x. Right? Now also think about this one. 50 minus 30. That was change in y in our earlier calculation. That is change in y when we're moving A to B. A to B. Right? So changing rate is gradient of this triangle. Change in y over change in x. That is changing rate. Can you understand? That is changing rate. So next, we also calculate movement from B to C. Then we can make this kind of triangle, right? The shape of triangle same. The degree of this one same, right? So changing geometrically, gradient of this triangle same. That is meaning of constant changing rate, right? That is first case. So now think about first derivative of this one, y equal fx, right? So first derivative of this fx is change in y over change in x, isn't it? Change in x, change in y is every time that is equal to 1. We already calculate. Or geometrically, this one. All the triangle have the same shape. So changing rate same. So we said changing positive, x increase then y increase, so positive, or changing rate greater than 0, right? That is meaning of positive. And constant changing rate same, like this. So we said positive constant case. Okay? Also now think about this kind of function, like this. fx is like this, right? X increase, then y increase, so positive, definitely positive. But we moving here to here, here to here, or here to here, something changes. Changing rate decrease and decrease, right? For example, you moving here to here, then we can make this kind of triangle, that is change in x, that is change in y, right? So here we'd like to graph x, first derivative, change in y over change in x, right? For example, that is 2. Gradient of this triangle at this range, that is 2. For example, 2 like this, right? But we moving here to here, we can make triangle. Then gradient of this triangle is changing rate, isn't it? This one is gradient of this triangle is smaller than 2, acute, smoother than before, right? So decrease like this. Decrease, for example, 1, right? And now you moving here to here, then we can make this kind of triangle. Triangle becomes smoother than before. That means changing rate decrease again, right? So in this range, changing rate is like this. So changing rate decrease, decrease, and decrease like this, right? Anyway, x increase, y increase, so positive. Or changing rate, this one is over horizontal line, right? Over 0, positive. So positive relations with decreasing changing rate, decreasing slope. Okay, positive decreasing slope case, positive decreasing slope case, like this. Also now think about this kind of function, right? fx function is like this. And similarly, that is x, that is change in y over change in x, right? Now what happened? When we moving here to here, we can make this kind of triangle. Gradient of this triangle is changing rate, isn't it? This one is, for example, half, like this range, half. When we moving here to here, we can make this kind of triangle, right? So that is change in x, height of this triangle is change in y. So gradient of this one is first derivative of fx function or changing rate. That is 1, for example, like this. We moving here to here, we can make this more acute triangle, isn't it? That means at this range of x value, changing rate increase. So we know that like this, right? Like this. So from here, anyway, we said changing rate increase. So we said positive increasing slope case, positive increasing changing rate case, right? Now think about positive. Positive means changing rate over 0, or x increase then y increase, positive. Increasing changing rate, increasing changing rate, increase and increase as value of x increase. Okay? So there are 3 types of positive relations in one-to-one function. Can you understand? So why I explain this? About more than 90% of equilibrium condition in economics based on changing rate rather than original function, right? So changing rate is something. Most of equilibrium condition in economics based on this changing rate case, right? So changing rate is, how can I explain changing rate? Changing rate, speed, growth rates have a same, almost similar concept, right? So a level function is y equal fx, x increase, y increase. That is true. But economists want more accurate information before a decision. So we focus on changing rate, speed or something. So most of equilibrium condition in economics is based on this changing rate. So positive relation classified into three. Positive constant changing rate case, positive decreasing changing rate case, positive increasing changing rate case. The changing rate is really important. Okay, then we move three types of negative relations. So until now we studied three types of positive relations. Now we studied three types of negative relations based on changing rate. So look at this. Same thing. Negative relation instead of positive. X increase, Y decrease. So negative. Relationship between X and Y, negative. I'd write, for example, at point A, X outside temperature 20. And consumption or demand for hot latte, hot Americano 50 unit. Okay? Outside temperature goes up 20 to 40 degrees. Then demand for hot Americano decrease because it becomes hotter and hotter. Okay? Outside temperature increase again 40 to 70. Then Y variable or demand for hot Americano decrease again like this. So negative, X increase, outside temperature increase, Y value, demand for hot drinks, decrease and decrease. So negative relations. So I said X increase, Y decrease. There are three types of negative relations. First one is negative constant slope case. Negative constant changing rate case. That the graph of this one is this one, okay? Like this. Read back to there. In this linear graph, we can calculate change in X from when we're moving A to B. At this point, point A is starting point, B is ending point. So change in X is XB minus XA. XB minus XA, so 20. Outside temperature increased by 20 degrees in Fahrenheit. Okay? Then what happened in demand for hot Americano? Originally 50, ending value 30. So change in Y, 30 minus 50, so minus 20. Okay? Then changing rate, by definition, change in Y over change in X. X increase, outside temperature goes up 20 units, then demand for hot drinks decrease by 20. That means this one. Outside temperature goes up 1 degree, then demand for hot drink decrease by 1 unit on average, in average. Okay? That is meaning of changing rate is equal to 1. Outside temperature goes up 1 degree, demand for hot drinks decrease by 1 unit. Okay, now think about when we're moving B to C. Then this is starting point, C is ending point. So we can calculate the change in X, XC minus XB. 70 minus 40, 30. Okay? And demand for Americano, ending value of Y minus starting value of Y. So 0 minus 30, so minus 30. So same, minus outside temperature goes up 30 degree. Demand for drinks decrease by 30 units. Then this means outside temperature goes up 1 degree. Demand for hot drinks decreased by 1 unit. That is the meaning of a changing rate. Okay, then we move graphical illustration of changing rate. Actually, we studied this at point A to B, for example. Changing rate is -1. Changing rate is -1. Outside temperature goes up 1 degree. Demand for hot drinks decreased by 1 unit. So that is the meaning of -1. Okay? So B to C, we moving here to here. Then what happened? Changing rate, same, -1. When we moving here to here, changing rate is same, -1. Okay? So graph is just linear function, negative linear function in original value. When we moving A to B, we can construct this kind of triangle. Width of this triangle is change in x. Height of this triangle is change in y. Here, change in y is negative number, so changing rate is negative. Okay? And or B to C, we can construct this kind of triangle. Shape of triangle, same. C to D, same. Or A to D, we can make this kind of triangle. All of this triangle have same changing rate, equaling to -1. Okay? Now, also think about slope. Definition of slope is absolute numbers of slope. Changing rate is -1 every time. So slope is +1 every time. Right? So in this case, changing rate is every time -1. Slope is equal to 1. So we say negative constant changing rate or negative constant slope case. Got it? Now we are moving to this kind of graph, right? We are familiar with this kind of graph. Think about production possibility frontier shaped like this, right? Value of x increase from here to here. We can construct this kind of triangle. Changing rate is, for example, -half. When we moving here to here, right? Here to here, then we can construct this kind of triangle, right? Shape of a triangle become steeper and steeper. That means -half, -1, -2, -3, like this. So changing rate decrease and decrease and decrease, like this. Decrease and decrease and decrease. That is changing rate. So we said negative decreasing changing rate case. Okay? Then what is slope? Slope is absolute numbers of changing rate. So this one is shaped like this. Right? So this case, this means changing slope increase as outside temperature goes up. So we said negative increasing slope case. So negative increasing slope case is perfectly same to negative decreasing changing rate case. In positive relations, changing rate is equal to slope. But in negative relations, different. Okay? So we can say this kind of thing. And third type of negative relations, outside temperature goes up anyway, demand for hot drinks decrease and decrease with decreasing rate, right? Decreasing slope, decreasing rate. That is third case, negative increasing changing rate case. So when we moving here to here, we can construct this kind of triangle, very accurate. For example, -3. When we moving here to here, this kind of thing, right? Triangle becomes smoother than before. For example, -2/3. Changing rate, -3, -2, -2/3 like this, at this range. Right? Finally here, changing rate is half, -half. Okay, so changing rate increase. Negative increasing changing rate case. And slope is this one. Right? Mirror image of changing rate. This one. Right? Slope. What happened? Negative decreasing slope case. Outside temperature goes up, slope decrease and decrease and decrease. So that is negative decreasing slope case. Until now, we studied 3 types of positive relations and 3 types of negative relations. Okay?